Hello. Wizardos here. We're halfway into our course, and I feel like you have a pretty good understanding of Linux right now. Talking about it, our desired distro comes with plenty of different apps, which you might have seen. You can play around with them, but what if we want some more? Yeah, today we're gonna learn how to install, configure, and overall what are packages and apps in Linux. So hold tight, get some tea or coffee, leave a like, subscribe, and off we go. As always, this is a pretty standard slide. It's a bit expanded since the last time. You can pause through it all, and if you feel the need to refresh some knowledge, head straight back to earlier videos and come back here when you catch up. But now, let's not waste any time and move forward. We're gonna start with packages themselves. What are these? These are archives of software and its components. If a package has precompiled binary, aka an app to straight up run, it's a binary package. If it has source code in it, it's a source package. Simple as that. To help us manage packages, we use package managers. They simplify the way we work with them, and they differ between operating systems. For example, we in Debian will be using APT package manager, which stands for Advanced Packaging Tool, while others, who use Arch, will utilize Pacman. On the other hand, someone with Red Hat based distro will use Yum, and the list goes on. But now, back to packages. There are pretty social creatures, as they rarely work alone. That's why in Debian there are plenty predefined relationships between packages. And that's also why Debian needs APT. Imagine going through the whole internet just to find one particular library that some simple program needs. Luckily, package managers resolves all these dependencies for us. And yeah, that's how you learn the first and most common relationship. Package depends on another when it can't run without it. But packages can also recommend other ones, which means they will provide some additional desired features like secure data transfer in browser. On the other hand, package A can suggest package B. Difference between this and the previous relationship is that B is not really necessary. Yet sometimes packages conflict, as they, for example, overwrite the same feature. For example, two versions of the same library. When the package installation does not go as planned, it might break on the way. But there's always a way to fix it. We're gonna learn how to do it. What we discussed here was viable solely for Debian. Other distros have their own package relationships, so check respective docs for more info. And now there's one question. Where do those packages even come from? Yeah, they come from repositories. Online, like some servers on the web, or offline, like CDs or directories. A repository is just a location that has a bunch of packages on it, available to download and run. To optimize the whole downloading process, the repositories have their mirrors and other servers that hold exactly the same content as the root one. The best thing about Linux is that it does exactly what we tell it to. Getting packages is no different here. We can define from where should our distro download packages in 3 different ways: via graphical interface, by editing sources.list file as root, and by adding custom files to sources.list.d directory. Today, we'll focus on the second one. How can we edit it? A source and sources.list file consists of 4 parts. First, we have the archive type. It says which kind of package is stored in that repo. It can be either deb for binary packages or deb source for source package. Then we have repository URL. This blue part here. Yeah. It's pretty much where the repo is located, on the internet or some directory offline. Then we have Debian's release. It can either be a number or a name. Another cool story is that Debian releases are named after Toy Story characters. The newest one is called Bookworm, and the next one is going to be called Forky. Last one are additional components. Overall, it's what the repo contains. The FSG compliant packages, they will be main. If there are no external dependencies, and contrib if they are. Non-compliant software has non-free components, and non-free firmware means firmware. That's necessary for some hardware, but not the FSG compliant. But what even is the FSG? It stands for Debian Free Software Guidelines, a bunch of principles that define what is free software in Debian and assures us, as users, that we can modify and redistribute the software as much as we want to. Down here, you see an example input to sources file. We'll probably see something similar when we move to our Debian, but right now, I think that's for packages itself. In my opinion, it's high time to introduce you to one important concept. Linux is sometimes different from Windows in the way they handle the new OS versions. The way we should know, so updates every now and then are called fixed release, or point release. But some distros adopted rolling model, which means they are having updates much more frequently. When point release, the distro gets a major update to its stable version every few months and years. Rolling distributions might receive them weekly or even daily. These ones have in mind only one thing when it comes to packages: as up-to-date as possible, while fixed release distro rely on stable but a bit older versions of them. This also means they require less maintenance than rolling counterparts, and their updates are larger in comparison. To give you some examples, point releases are Debian, Ubuntu or Mint, but Arch, Manjaro or Gentoo are on the other hand rolling release OSs. And now, important question arises: which one is better? Answer is always, it depends. Keeping packages up to date and very frequent updated didn't mean little time to test them. So such errors occur much more often in rolling distros. On the other hand, point release lack these fresh patches for many software, as well as might not have drivers for the newest hardware published. So in my opinion, fixed release distros are the best to be used on servers if you don't mind being a bit behind. Yet if you really like playing around and some system crashes are not scary for you, or you just bought the newest GPU and can find firmware and drivers anywhere, get some rolling distro. Alright, it should be everything you need to know for today. Let's jump into the lab and install some cool packages. Alright, welcome to our Linux. Before going into our journey with APT, we're going to start with something else. First, we're going to use dpkg. dpkg is a package manager, but offline. Pretty much you can install with it using -i. You can install local packages that, if you have files of them, just .deb. There's plenty of these, but the main difference between APT and dpkg is that dpkg does not resolve any dependencies. So if a package needs some library that is not present in a repository, then yeah, you need to find yourself. But APT does it for you. Also, APT needs to be run as root, so if you're running as a user, you can just add sudo at the beginning, but here, for the sake of simplicity, I just switch to root. First thing you need to do before running anything regarding to APT is to run apt update. It's going to update repository lists. Pretty much, it will take everything from sources.list file or sources.list.d directory and check all the repositories there. Are they alright? Are they available? And yeah, that's really about it. Now, how to install a package. Let's start with this thing. To it, use apt install. Let's choose Apache 2. Now, we are here present with this prompt. Do you want to continue? It's going to be always. And for example, if you would like to install more packages, such as I don't know, Apache 2, PHP, it's going to pop out again. So to skip it, you can just add, let's do PHP, you can just add -y. This is going to skip the prompt and just assume, yes, I agree to everything. Alright, let it install, it's not going to take long. This will install the newest version available in the repositories that are listed in sources.list file. But what if we want one specific version? You can do it by just adding =, and here a version, like let's say 201. There's another version like that for Apache available on the repositories. But as you see, it read correctly. Now what if we have a package, but it's pretty old and we need to update it? We use install as well. And the only thing we need to do here is just add -- only upgrade. Running, clearly just up install Apache 2 again would do the same thing, but it's always better to run this with only upgrade. But now, what if we want to remove the package? Let's say Apache got bored. We can use apt remove Apache 2. Let's type in yes, and off it goes. Also, when I uninstalled the package just itself got uninstalled, and not really everything else. So then to remove unused package, unused dependencies, and all the recommended packages that were installed before but are not needed right now, you can use APT. To be honest, APT auto remove. As you see here, there are two packages that should be removed because these are packages for Apache, and Apache is not present here. So you can just type in yes, and off it goes. Connect to installing. We do not always want to install a package. Sometimes we want to move them around computers and we want to have them cozy, typical file format. We can do it by adding to apt install one of the parameters called -d. No, not slash. Sorry. I'm gonna remove it pretty quick. Yeah. With -d. Yeah. And this way is going to download me a package file, which then is going to store in /var/cache/apt/archives. Let's go to /cd var cache apt archives, and let's list all. I have Apache in it. You see, packages get downloaded, and they are all there. All right, let's go back to apt and to deleting, because sometimes during installing, deleting, whatever, something might go wrong and the packages might not be broken. apt has its own, let's say, troubleshooter. You can run with apt install --fix broken and a command and a package actually. There are plenty of other important options for it, such as, for example, -s, which stands for simulate, which is going to perform all the different tasks as if they were installed, but actually nothing was installed. Then we can also run --reinstall if a package does not work correctly. We just want to reinstall it. Install Apache 2. It's going to install a package, but right now it's going to just solely install it. I don't want any more mess on this. If we are downloading packages from the source, which you should know what are source packages, then you need to build them as well. apt can do it by just adding -b option. Alright, I think that's it you need to know for apt. We're going to look into one more place, which is going to be in etc. You can find that file in /etc/apt. Here is sources.list. Let's cat it. Sources.list. And you see here we've got a bunch of entries. First, as we have mentioned in the presentation, is the type of the archive, which here means the archive storing binary packages, and this one stores Debian source packages. Where it's located, for what Debian. Here I run Debian Bookworm, so it's for Debian Bookworm. And about what packages are there, which is main and non-free firmware. Main of the package is the FSG compliant, I mentioned it, and non-free firmware, only firmware needed to run. Alright, I think there is nothing more to tell you about it. So thank you so much for watching. I hope you enjoyed this little intro. Leave your thoughts down below, subscribe, hit the like button, and yeah, that's I guess really about it. Again, thank you so much for watching, and see you next time in another amazing material. Cheers!